One is the physics paper 4 mock set 4. The question 8, in question 8, figure 7.1 shows a ray of a light that passes through an optical fiber. The light will undergo a total internal reflection. So the optical fiber is made up of a glass that has a refractive index of 1.4. No light refracted from optical fiber at point P and Q. State the name of this process occur at P and Q. So what we call this process, we call that as a total internal reflection, because light undergoes a total reflection when the angle of incidence is greater than the critical angle. Then calculate the minimum value of angle of incidence for no refraction to occur. So we need just a critical angle here. So n is equals to 1 over sine c. That's the formula. So if I need, so sine c is equals to 1 over n, or c is equals to sine inverse 1 by n. So sine inverse 1 over n, that will give us the value for the critical angle. So the refractive index is given. The refractive index is 1.4. So we'll see, right, c is equals to sine inverse 1 divided by 1.4. And take the sine inverse of this number. So we'll get the critical angle, that is 46 degrees. State and explain the use of optical fiber in the medicine. So how optical fiber is used in the medicine. So an optical fiber is used in the medicine to examine the internal organs, which we call endoscopy. So what will happen? The light passes down the fiber and it is reflected back, and like eliminate the organ, I mean, and we are able to see the organ which is inside. So it is used endoscopy. The light will under total internal reflection, passes through optical fiber or a fiber optic, and eliminate the organ. Next is a ray of a light shown in is a monochromatic. Monochromatic means light with a single wavelength. Light which is having only one wavelength or a single wavelength, we call that as a monochromatic. So the distribution of the marks here, one mark is for mentioning a single and one mark is for mentioning the frequency, because we don't have a wavelength. As I mentioned, we have to use one term, one of the following quantity in our answer. So one mark is for using a frequency, one mark is for single. A student makes a transformer that uses an alternating current supply with an EMF of 12 to an output of 2. So student is provided with two length of insulated wire and U-shaped piece of iron on a complete show transformer. This is a step down transformer because in EM 12 volt is there, converting into 2. So input will have more turns because it's a step down, and the output we will have less turns. And show that they're connected to a supply. So it's this part is connected to a supply. State and explain the function of a piece of iron in a transformer. So what is the function of piece of iron in a transformer? Iron is a soft magnetic material, so it can easily be magnetized or demagnetized. So it is used to link the magnetic field from primary to secondary, or to have a better induced current. The main purpose is to link the magnetic field. The output of a transformer is connected to a lamp. The current in the lamp is 10 milliampere. It is 100% efficient. Calculate the input. So VP IP is equal to VSIS. If a transformer is 100% efficient, the input it was 12 volt. The input current we don't know. The output was 2 and the output current is 100 milli. So it was 100 into 10 to power minus 3. This is 12 is multiplied. Other side it will be divided. So IP is equals to 2 times 100 into 10 to the power minus 3 divided by 12. That will give us the input current of a transformer. Another transformer is used in a school lab to step up a main supply from with the potential of 100 and to step down actually to 110 to 12. The transformer is mounted on a metal case. Extend and explain essential safety feature. So because it's on the transformer is on a metal case, so that the metal case must be earth, so that it will protect a person from getting an electric shock. Like in case if a wire touches the metal case, a person will not get an electric shock as it is earth. Question 10, figure 10.1 shows an incomplete circuit. A student completes the circuit by measuring the current in a 6 ohm resistor. On a figure, draw an ammeter in a gap and straight lines to indicate the wires, another gap. Because the current enter in this region and it will divide and then it can recombine. So current here will be same as current in this part. So I should connect an ammeter between A and B, and C and D will be the straight lines. A voltmeter to measure a potential across a 4 ohm. So I need a voltmeter, connect a voltmeter in parallel to 4 ohm supply. On a figure, draw a voltmeter, we connected. Then with the circuit completed, the current in 2 ohm is 2.5 amp. So current is 2.5 ampere here. Question is calculate the current in 6. So first we'll find the voltage here across this one. And the voltage here will be same as voltage here. V equals IR. I is the current 2.5 and the resistance is 2. So the 5 volt is, so voltage here is 5. So this voltage will also be 5 because they are in parallel. And if you need the current, so V equals IR. So V over R is equals to I. V is the voltage, that is 5. And R is the resistance 4. So 5 divided by 4, that is 1.25 ampere will be the current. So 1.25 ampere here and 2.5 ampere here. So what is the total current? 2.5 plus 1.25. So 3.75 is the total current which entered the circuit. But we don't need the total current. We just need the current in the 4 ohm resistor. Now, figure 10.1 shows the same electrical circuit with an AC supply. On a figure, draw a diode. So that there's a current from right to left. So we want a current to flow from right to left to a 4 ohm. So we want to current to flow in this way. So how a diode should be connected in a conduction mode. So this is a conduction mode of a diode. And here straight line because we want an AC supply in the 2 ohm alternating current. So if this is positive, diode will allow. If negative, positive and negative, diode will block the current in the 4 ohm. State two differences between the nuclear fission and fusion. In nuclear fission, it is a breakdown of a heavy nucleus. Where fission is a lighter nuclei is joined to form heavy. And fusion produce more energy than fission. A radioactive tracers emit a gamma, which can be used in medicine. The half-life of the source is 6 hours. Why a source of a gamma is used in this way? should not have a half-life shorter or longer than 6 hours. If it is shorter than 6 hours, if the half-life is less than 6 hours, so what will happen? The scan cannot be completed, because if it is less than 6 hours, the scan cannot be completed. And if it is longer than 6 hours, then what will happen? It will be dangerous. Why? Because it can remain in the body for a longer period of a time. So it might be dangerous. Then we have to complete for a beta decay, the nucleon number does not change and the proton number increases by 1. So this is for beta. State another use of radioactive nuclide in the medicine. So it is used for a treatment of a cancer or a radiotherapy. Astronomers claim that there are about 300 billion stars in the Milky Way. Describe how the stars are formed. So we have to explain the formation of the star or the star cycle here. So how stars are formed? First, we have a planetary, like we can say a nebula is there, or a dust and a gas in from the space is pulled together and by a gravitational force, and that gravitational force, so the dust and the gases in the space pull together and start fusion, releases energy, which form star. Just a basic idea about the formation of the star. The next is use the correct answers from the box to complete a sentence. Energy released by in the star by a process is a nuclear fusion. Why star is stable during a main sequence period, main sequence or a stable star when the radiation pressure is equals to gravitational force, or a radiation pressure balanced with a gravity. That's why the star is stable. Then the life cycle of the star after the main sequence period depends on the size of the star. A particular star in the same as the size, so it's a low mass star, and the stages are there. So we have first a main sequence. So protostar is not mentioned. Then it will be a red giant. Then it will be a planetary nebula. Then it will be a white dwarf. So these are the sequence of the stars.